Hello and welcome back to Isomath. Now we're still dealing with radians. Now we want to find some special angles and endpoints on the unit circle using the radians as our angle measure. So let's first try one here. Let's try pi over 6. We want to find out the endpoints that correspond to an angle of pi over 6. So to do that, we just like we did in the section before this, we want to find out what endpoint does that correspond to? Remember, that endpoint is my x value, the distance that I have to go in the x value. If I drop a perpendicular line down here, I need to find out that x coordinate. That forms a perpendicular line, and I need to find out the y coordinate, which is nothing more than the height. This is how I do that. So pulling the triangle out, you can see here that I have an angle of pi over 6. I have this right angle, and I have this angle up here. Well, we found out also in our previous examples that a right angle or a 90-degree angle in radians is nothing more than pi over 2. So I have pi over 2, I have pi over 6, and then I have my mystery angle up here in radians. Well, we need to draw back on what we know about triangles. Remember, all triangles have an internal angle measure of 180 degrees, which in radians is equivalent to pi radians. So they all have pi radians. Well, that means that if I take these three angles and add them up, they need to total pi. So if I have pi over 6 plus pi over 2 plus my mystery angle, they all have to total pi. In solving for this mystery angle, you can find out that what you end up with is pi over 3. So that's my missing angle, please. So this angle right up here is pi over 3. Now think about this. From our previous unit, we've actually encountered these before. When we solved this problem using degrees in the earlier section, this essentially we know that pi over 6 is equivalent to 30 degrees. This is equivalent to 60 degrees, and this is obviously equivalent to 90 degrees. And when we solved this triangle, we found out through doubling and all that good stuff that the side opposite 30 degrees on the unit circle, the triangle, the side is equivalent to 1/2. We know that this is the hypotenuse, and since this hypotenuse lies on the unit circle, it has a radius of 1, therefore that has a length of 1. And the side opposite the 60-degree angle down here had a measurement of square root of 3 over 2. And it is such the case as well on the unit circle when I'm in radiant form. So this point right back here, that essentially has an x value. Since we know that this is the bottom length, this has a square root of 3 over 2. This has a height of 1/2, and it has an hypotenuse length of 1. So my end point there is the square root of 3 over 2, comma 1/2. So my radiant of angle of pi over 6 has an end point on the unit circle of square root of 3 over 2, comma 1/2, which is my x and y coordinate, which will also become, as you'll find out in the near future, essentially your cosine and sine measures. But we'll save that for the next lesson. So our measure of pi over 6, which is equivalent to 30 degrees, have the endpoints on the unit circle, square root of 3 over 2, comma 1/2. Now let's find out what the measure of pi over 3 has as endpoints. Let's find the endpoints for pi over 3. So we're looking for these endpoints. Well, we solve this similarly to what we did before. We're going to drop down a perpendicular line. And again, all we have to find out is our x and y. We know that's a perpendicular line. So if we're coming over here looking at this triangle, I know I'm going to form a perpendicular line there. And I'm going to have my endpoints essentially here is going to be 1/2 pi. And we know from this is nothing more than the other triangle we had flipped on its side. This is going to end up being pi over 6. And if not sure, you can set all angles total equal to pi and solve, but it's end up going to be a pi over 3, pi over 6, pi over 2 right triangle. This one's flipped over on side. And we know from our previous example that the side opposite pi over 6 is always going to have a value of 1/2. And the side opposite pi over 3 is going to have the square root of 3 over 2. And we know since that has a hypotenuse on the unit circle, it has a measure of 1. So in this case, our endpoints are going to be 1/2, comma, square root of 3 over 2. So this has a distance of 1/2, and this has square root of 3 over 2. That's obviously 1. So an endpoint that corresponds to pi over 3. So we have pi over 3, which we can use a conversion, but is essentially the same as 60 degrees. Have the endpoints 1/2 square root of 3 over 2. Now let's take a look at another example. Taking a look at the radian measure of pi over 4, we want to find out this endpoint on the unit circle. Again, we're in radian form, so drop down a perpendicular. That's going to form a right angle. Taking a look at that triangle more closely over here, since we know this forms a right angle, that is going to be pi over 2. And again, we can know that pi over 4 plus pi over 2 plus this mystery angle plus the mystery angle has to total pi, because all triangles have a total radian measure of pi. Well, doing some math, we can know that this missing piece is also pi over 4, because pi over 4 plus pi over 4 plus pi over 2 is equivalent to 1 pi. So that means our mystery angle in radian form is another pi over 4. That makes this an isosceles triangle. We know that this is the hypotenuse on the unit circle over here, has a value of 1, so this has a value of 1. The question is, what do these two legs equal? Well, in an isosceles triangle, not only of these corresponding angles are equal, but also these side lengths are equal. Therefore, this side has to equal the other side. So we're going to call this just simply A, and rather than call this B, we're going to call this A as well. And using our Pythagorean theorem, since this is indeed a right triangle, we know that the old a squared plus a b squared equals c squared, but in this case, a squared plus the other leg squared is equivalent to the hypotenuse squared, which is 1 squared. So we're left with 2a squared equals 1, and that obviously comes out to being a squared equals 1/2. And taking the square root of both sides, we're left with a equals the square root of 1/2, or simply, after rationalizing the denominator, a equals the square root of 2 over 2. So these two side lengths over here have a value of square root of 2 over 2 and square root of 2 over 2. So that makes this endpoint the square root of 2 over 2 comma square root of 2 over 2. So we found the endpoints corresponding to pi over 6, pi over 4, and pi over 3. Well, let's find the endpoints with a radian measure of 0. Well, with 0, the endpoint simply puts me right there, which has obviously an endpoint there of 1 comma 0. And if I go to 1/2 pi, that's going to put me right here on the circle, on the unit circle, and that obviously corresponds to an endpoint measure of simply 0 comma 1. And last but not least, pi, which is equivalent to 180 degrees, is 1/2 way around the circle, puts me right there. And that obviously has an endpoint of negative 1 comma 0. So here are the endpoints of my special angles in radian form, and their equivalent in degree form. We really need to get comfortable with these. You need to know these like the back of your hand, because these are the ones we're going to be using. I hope this is helpful. Remember, check back through ISOmath with all your math needs, and we'll see you soon.